So today we are going to talk about PLAN and some other formal methods work which we do at Resonate. I'll also be talking to Dominic, who is CEO of Resonate, whether formal method would make sense at all. Are they just academic thing or they have real world use? Gabriel is also a founding engineer at Resonate, and I was able to get him on the show. So, Gabriel, we will start with a short introduction of yours, and then we can start the discussion.
Okay. Okay. My name is Gabriel. What should I say? I'm from South Florida, born and raised. Went to the University of Michigan and been working in startups in like the cloud space for a couple of years now, and I've been working at Resonate since 5 months ago. Yeah.
So, how did you get to know about the Resonate, and how were you able to join the team so early?
Yeah. I mean, a lot of it had to do with Dominik's book, Thinking Distributed System. So that's how I first even heard of Dominik to begin with. This was like early last year, and he was you were posting it like once a month, right, Dominik? Something like that.
Yes. One chapter a
And
month.
yeah, after reading like the third chapter, like I started like a small book club with someone that I was working in my previous job, and we were reading it. And I just really like the approach to like really technical concepts. I think there's a lot of like smart developers in the world, but not many smart and great communicators. And so that definitely attracted to me because I was trying to just make sense of distributed systems and software, and I got a lot of clarity from reading Dominik's work, and that's when I reached out to just chat. And that was it. It was just chatting about the industry, the book, the work, and then there was an opportunity, fast forward 6, 7, 8 months or something like that after we spoke, to join the team, and I was excited to do so. So yeah.
Before we move forward, I would also like to understand and ask what responsibilities are you handling at Resonate? What are the things you have done so far? And I know that you also have a blog out. So how was that experience?
Yeah, so I primarily work on the server side. So I guess we have two components to our programming model, the SDK and then the like durable execution engines. And I work on that part. So it's mostly Go programming and some of the features that I have been working on for the past month. It's been like stuff like distributed lock-in APIs, our schedule API to create promises or just activities in a schedule. And currently I'm working on the task framework, which would enable like sort of fan out patterns for our customers and users. And that's kind of like the basis of the blog. So as like getting to the design of the task framework and how that communication would work with, let's say, a set of workers on one side and then a service on one side and the durable execution right in the center. We with the help of Dominik, we like mapped and designed the actual protocol, and we wanted to use a formal modeling language like P to be able to just iterate quickly through the design before actually getting to the implementation. So we did that for a few weeks before we settled and agreed that what we believed our assumptions to be were clear enough to move on to implementing it in Go.
Okay. So now I would also want to ask Dominic because I have mostly seen either really big players like AWS, Microsoft working with formal methods, or I have seen academicians writing proofs in Cork and Agda. So where does formal methods come into the picture in Resonate, and why are you so pro formal methods, if I can say that?
When we talk about formal methods, we're actually talking about my biggest regret in my career. So you can argue my biggest professional regret. And that was the very first time I came across any formalism was in college with two very brief encounters. One was Poirot logic, and the other one was a formal specification Z. And I only looked at it briefly. It was also not, I want to argue, it was not introduced well. It wasn't introduced well enough for me to understand what it was. So then for the longest time, I did not pick up formal methods. And then somewhere around, I believe it was around 2013, maybe 2015, I came across TLA plus, the temporal logic of actions. And I was interested, and I slowly got into it. And then I noticed what I was missing out on. And it goes beyond the formalism itself to a way of thinking, right? So what formal methods are for me are first and foremost a thinking tool. They help me to think about complex systems. Right? And concurrent systems and distributed systems are inherently very complex systems that are defined by basically a combinatorial explosion of possibilities, right? Is it going to be step A in process 1 first, or is it going to be step B in process 2 first? So, and with the number of processes and also with the number of adverse effects, like for example, crashes or message losses, you have this combinatorial explosion of things that can happen that are very, very hard to think through. But formal methods first have the tools help you to actually explore this space. But the formalism alone already sharpens your thinking to a degree that now a human being can actually think through this jungle of possibilities. So that is what embodied formal methods for me, and it is to this day my biggest regret that I got into them so late.
And using formal methods to think about resonates programming model and other problems which we are building at Resonate. How does that give you confidence? Because mostly I have seen formal methods being used at bigger cloud organizations. So why do you think formal methods are a good tool for even for a small scale startup like us?
So the model that Gabriel maybe is going to shed some light on in this talk later is a task framework, right? And tasks, basically the guarantee you want to make to the user is that your task is going to be picked up and completed, right? That is basically the heart of a task framework. And when we look at Resonate, there is already a huge variety of third-party infrastructure we want to support. So, for example, tasks delivered via HTTP, tasks delivered via message queues. Message queues have different delivery semantics. Is it as most once delivery or at least once delivery? Do they allow message reordering or message duplication? And which would basically be at least once. So message reordering, right? And so to ensure that we can actually give you this guarantee of completion across all of these different methods, you have to think through many different possibilities, many different interleavings. And that is where formal methods really, really shine, right? So once you encode your environment and its different possibilities, at least once, at most once, message reordering, you can actually run your protocol before you even implement it. You can run your protocol through all of these different scenarios and see if you can deliver this guarantee that you're making to the user, right? So before you write a single line of code, you already know that your protocol, your algorithm is correct. At that point, you do not know that your implementation is correct. That you do not know, right? But you know that your protocol is correct. There will not be a surprise on the protocol level. So you come in with an incredible confidence that at least like for me, this confidence accelerates my work. So you come in with an incredible confidence. And number two, at this point, you are only battling bugs or looking for finding and eradicating bugs in your implementation, but not conceptually. And if you get whatever you get wrong conceptually, it's going to be very costly getting that right. Whatever you get wrong in the implementation, not so bad if you can still stick to your concepts.
Hmm. So even the blog which Gabriel wrote, and we'll link the blog in the description below. He mentions that using formal methods as a thinking tool helped him in detecting the design issues early. It also serves as a documentation and just an anecdote. So while I was implementing Raft, I took TLA plus spec as um, a documentation for Raft, and it was like really helpful because, as you said, Dominic, that we don't have to worry about algorithm and everything. It is written, it is a spec written in a very detailed, nice way. So you literally have to just copy those spec in the code, like take a part of the function and state transition and model it. Now, Gabriel, I also want to ask you, you mentioned a tool in your introduction named as PLang. So what that is, because TLA plus and these things are a little popular. I have not uh, heard of PLang. So what that is, and why did you decide to use it?
Yeah, so as Dominic mentioned, he's a big fan of formal methods, and for me, it was always like a peripheral thing. I heard about I heard about TLA plus, but I'm not the fan of like the syntax, or like it looks very intimidating to me. And I always thought about it as like this esoteric thing that like academics do mostly. So for me, it was never like in the cards to even learn about this. And I think through Twitter, I forget somewhere, maybe I just heard of P, and immediately I was just intrigued just because like it looked like more like code. It didn't look so mathematical. And that's mainly because it like I mentioned in the blog, it translates a lot of like the stereotypical formal method like concepts into methods or concepts that software engineers already know. So for example, like a service, you can define it as a state machine, a request you can define as an event, and the behavior of the system, what you expect it to have, you can define it as safety and liveness properties. And so that was very appealing for me because in general, I like learning things, so it's something that I wanted to get into. The space seemed interesting, and it seemed like an approachable way. So that was the main thing, just the approachability of formal methods.
And if I'm not wrong, you did this exercise along with Dominic, right?
Yeah, yeah. Dominik helped because again, like I had never done formal methods before, so it was
Mhm.
a lot of like conceptually, it took me a few tries to even understand the the how I should be thinking about it, or like at least like what was the goal? Because like
Mhm.
with P, I think it's easy to get lost because it looks more codey than TLA plus, but it's easy to get lost in too much of the details of the implementation. And so kind of knowing the nuances of what to conceptualize out versus what to actually implement. Like for example, we don't actually model a server, but we model a task, and then a worker picks up a task. So stuff like that, working with Dominik, who obviously has a lot of experience in formal methods, was useful.
Mm. So this was like, according to me, a good achievement, and it is. I'm so happy to see you progress and pick up new tools at Resonate. So, just a quick tips, Dominic, if you have to share anything. How do you make somebody like Gabriel, who has never worked with formal methods, rather he was scared with TLA plus syntax, pick up PLang and do, and he literally wrote the whole spec. And we'll talk about the spec later on. But how does that mentoring process look like?
With Gabriel, gotta say it's like super straightforward because as he already mentioned, right, it's like curious mind. So Gabriel was super eager, right, to it's like to apply formal methods, and I was super happy that he is interested in that too, because I also do not get to collaborate on a formal specification that often. So I was also super happy. And it was one of the first times where I where I was the more experienced one in formal methods, and somebody basically like walking side by side, right, like working together, was one of my first times too. So I did enjoy that, and I did see, like, I could pick up on what Gabriel was saying. That's why I nodded along. Formal methods, you really have to think above the code, right? And TLA plus makes that a bit easier because TLA plus doesn't even look like code, right? So it does not lull you into this familiarity. Now, this is good and bad, right? Because on the other side, it's also like very, very alien, and it can be somewhat intimidating. But you wouldn't necessarily even try to code in TLA plus, right? It itself doesn't offer itself or lends itself to that approach. Plang looks more familiar. It looks more like a programming language, but then it is easy to immediately start programming in it. But that's not what we're trying to do, right? So trying to think above the code. And there were just a few points that I noticed as soon as Gabriel familiarized himself with and wrapped his head around them. He was already like exponentially better with Plang. I remember vividly, one was the non-determinism operator, right? Where we were, I believe, the first time we applied it, we were implementing a failure scenario. And Gabriel first was approaching the failure scenario like we would probably approach it in code if we wanted to simulate a failure. We do something 3 times, and on the 4th times it fails. Or the other way around, we fail 3 times, and then on the 4th time we succeed, right? But that is unnecessary in Plang, because in Plang and most formal methods, non-determinism is your friend. So you can say, now explore the behavior space if it succeeds or if it fails, right? It is basically a branch in the flow, a branch in the behavior. And you just specify the existence of the branch, but the tool will then basically explore all of these forks in the road for you. And we had 2 or 3 of these like moments where something like non-determinism or like abstraction in the sense of don't even look at the value. It doesn't really matter, right? So we are not doing anything with the payload. So just ignore the payload. Just don't even model it, right? So we had a few of these, really only like 2 or 3 of these like moments, instances, where was like, and now I'm kind of speaking for you, but it's like from my point of view, it was like a light bulb moment, right? Where you see, oh, first light bulb, bump, 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 yeah. And then from there on, boom, it was like, there was this way of thinking that and Gabriel applied to the specification that made everything like just straightforward. Again, this is not I'm talking for you. I don't know if you felt it was straightforward, but it's like from my perspective, it was yeah, the first few switches that we flipped or locks that we unlocked, and then was very, very productive, very, very quick.
No, yeah, I definitely believe, especially when you're talking about the non-determinism of like the dollar sign, the true or false. That really did help me see, because I wasn't, yeah, I was thinking about it too much as code and trying to like implement basically the entire protocol as needed, and not leveraging, I guess, the tool of P and the discovery that it does itself, right? So then I started to think about it more as a declarative type of thing that then P takes on and then does the kind of like a search path throughout all of the scheduling. Yeah, and I mean the non-determinism didn't just stop with like the message loss, but like even the timeouts and the shutdowns all came from that sort of thinking. So yeah, definitely unlocked after that point.
So, is this work open source, Gabriel? Is it out for the world to see, or we are waiting on that?
Yeah, no, the repo is open, so we have P Resonate workers under our Resonate HQ organization on GitHub.
Mhm.
There you can see there's 3 folders: pspec, psource, ptest. So pspec has our safety and liveness specifications. So again, that was great to think through. Um, the P source has the actual state machines and events, and it kind of sets the stage. And P test sets the environment. So in our
Mhm.
model, at least, we created one task and 2 workers that compete for that task. And then once you run, and then if you just install P checker, you compile it and then run it, you can do hundreds or thousands of different interleavings of schedules and stuff like that, and check it out for yourself.
Hmm. So, talking about these two properties, are these things general for any distributed system that wherever you come up with a algorithm, a protocol, then you for writing specifications, safety and liveness is something which you have to verify always, or is it special? Was it special for our thing?
Dominik, do you want to take this? Because we just talked about it this morning, I think, right?
Yeah, I can take it. So indeed, so systems are generally described in terms of 2 different properties: set of safety properties and a set of liveness properties. A safety property is, informally speaking, a safety property is an assertion that nothing bad will happen, right? And a liveness property is an assertion that something good will eventually happen. And indeed, these are general properties. There is a formal proof that every single property of a system can be expressed as a combination of safety and liveness properties. So whatever your requirement, it can be expressed as safety and liveness properties. Now, that formal proof is out there. It's very hard to understand. I did not understand the proof, why that is actually true. However, it's like people smarter than me vouch for the proof. So I just accept it as fact. And yeah, in practice, I have also not like encountered any difficulty in expressing the properties of my systems that I am particularly interested in. And in general, safety properties are the properties that are easier to express, because often you only need to look at the current state of the system and see if the current state violates an invariant. For liveness properties, you cannot look at any one state. You may have to look at and it's like basically an infinite behavior. But with safety properties, you get very, very far, because that is also where a lot of our focus in software engineering is, right? That we say we never want anything bad to happen. In software engineering, we do not actually enjoy unlimited liveness guarantees, right? Because we cannot guarantee that the carrier system, the hardware, is up. So we may experience a crash at any moment, and crash after recovery, we cannot enforce or there's like work progression on any liveness guarantee. But we must make sure that at each and every point our systems are safe. So there is a huge focus on safety properties. First, because again, they are simpler. Second, they are like very prominent. Whereas I also have to say at the same time that the formal methods community is very vocal about not ignoring liveness properties, right? So it's like the formal method community is very encouraging towards everybody to also think about their liveness properties, encode their liveness properties, and check their liveness properties. But yeah, it's very common that it's like the safety properties get a lot of focus.
Interesting. Gabriel, I think you also got a chance to talk to the creator of Pelang along with Dominik. So how was that experience like? What all did you discuss? What all how was the experience like? Did you enjoy it? What are your thoughts?
Yeah, no, I mean it was pretty cool. It's not often you get to meet the person who designs the tools you're working with. So that was a fan moment for me. He was very nice. We just discussed like in terms of like best practices and stuff like that. And I mean, one thing that stuck with me from the conversation that I thought was interesting was um, you have this basically graph of path that your server or your system can go through. But actually knowing which ones to search through that would actually be convenient to find bugs is actually quite a hard problem. So I remember at the end he shared a paper. If I find it, I'll mention it at the end or put in the link. And that's interesting, just how much thought there is in put into these toolings. It's not trivial. All the possibilities and basically the combinatorial explosion that is distributed systems and how easily bugs can hide in one of those paths.
Interesting. So the last question from my side is, what are you guys reading currently, Dominik and Gabriel? Dominik, I know for sure because he keeps sharing and he keeps buying all the books he sees on Twitter. So what are you doing, Dominik, and what are you reading, Gabriel?
So you can go first, Dominik. I'm trying to find the two books I'm reading.
Oh, you could do that too. I did not. I don't have any display material.
Step it up,
prepared.
Dominik. Come on.
But yeah, it's like I posted on Twitter. I can resist anything but temptation, and I'm never as tempted as when I see somebody recommend a book that I don't have. Yeah, then just like, and especially when they speak highly of it. Yeah, then I must have it. So currently reading a few different books. But at the very top is the original book of Jim Gray and Andreas Reuter, the OGs of transaction processing. So when I saw the book, somebody was posting on Twitter. They were posting snippets about the book, and I'm a huge fan of Jim Gray's writing. He has an amazing mental clarity when thinking about database systems, concurrent systems, also distributed systems. Amazing clarity that he can also really well articulate. So I was always a huge fan of his papers. And then I saw somebody posting snippets of that book, and I mean that was like at that moment it was too late. So then I headed over to Amazon and ordered the book. And then basically 2 days later, I get this huge package. Yeah, there's like, I didn't think that was the book. Yeah, so I got this huge package. I was like, what did I order? Yeah, and then when I unpacked that, it was the book about transaction processing. Which as soon as Gabriel is going to show his book, I'm going to go off screen and look for mine. Got this huge book about transaction processing that will keep me busy and happy for a very long time.
Gabriel?
Well, I'm definitely not as cool as Dominik. I don't have a big book on transactions, but I almost never finish books. It's a bad habit. I tend to like skim around and see what I like. So there's two books I'm kind of skimming around and seeing what I like. The first one, I took the cover out, so you can see the cover, but it's called Inspired: How to Create Tech Products Customers Love. This one I love because I'm a fan of Marty Kagan. He works at Silicon Valley Product Group. That's his company along with other product people. And I just like how he articulates products. It's honestly, it reminds me a lot of how Dominik articulates systems. It's this guy thinks a lot about product in a similar way, and we're building a product, so I like to read stuff about that. And then the second one, this was Read Write Own. It's a blockchain book. I'm not actually into blockchain, like I've never really worked on it, but there's a lot of distributed systems work in blockchain, and conceptually, I think I like the energy of Web3 type stuff. And this was written by a partner in A16Z, and so I was interested in his opinion about the space, and I also liked it because I read snippets before I bought it, and in general, he tries not to use buzzwords and tries to like really articulate what he actually means. So I think it's very common in like Web3 in the space to just say, it's distributed. It's great because it's distributed, but what does that actually mean? And he kind of drills down. So I like that.
Dominic, want to show the book?
Yeah, let me see if I can fool you with the 2D view first, and then I tilt it so that everybody basically is shocked how big it is. Yeah. So this is the book, and then it is really that big. Yeah? So it was a huge package. Yeah. And
Wow.
this book, yeah, is going to keep me busy for a very long time. By the way, I would like to add something to what Gabriel said. And there is just a lot of material out, right? There is a lot of books out. There's a lot of papers out. There's a lot of blog posts out. So we don't have a shortage of information. We have a shortage of time, right? So I am also a huge believer in I'm not sure that there is a term for it, but let's say either skim reading or partial reading, right? Where you find the aspects either within a chapter or within a section that you are most interested in, and then dive into these aspects or dive into these fragments. But I also have most of the time not actually the luxury of time to read a book cover to cover or read a paper from beginning to end. So that I think is in itself is a almost a skill that you have to hone, right, to get value out of the many sources we have at our disposal, right? But not the actual time to study each and every one in depth.
I would like to add, because this is one of my favorite topics to talk about. Nassim Taleb is a mathematician and also an investor. You might not agree with him with everything he says, but he has a concept of anti-library. He says that we as humans are so much, trained to think in terms of ornaments and possessions. For example, in our resume as well, we write all the things we know. So we start treating our knowledge as something to protect, as a ornament to show. So the library should also always be the things you have not read. So, but people do it the opposite. People keep the books which they have finished or they have read. So, if you have, and it is okay to skim through books, like because every time you read something, you get some ideas too, and you let that thought simmer, and then it matures to something. Reading things end to end may not make sense always. So I just wanted to add there. So with that, I think we have discussed what resonate with formal methods. A lot more stuff to come in coming months. Just to reiterate, Dominic, what can the listeners look for? What are we, rolling out soon? What will make them excited?
Yeah, for next month, we have our very first release candidate to release. I was, let's say, overly eager, and I wanted to release on the 1st of April, but then you guys basically told me, don't do that. Then everybody thinks it's an April Fool's joke. So now our official release date for our first release candidate of Resonate is April 2nd, which this year falls on a Tuesday. That just feels right. So Tuesday morning, PST, we plan on releasing first release candidate of the Resonate SDK and the Resonate server. So the very first time that we release a release candidate of Resonate's vision of distributed async await.
All right. So with that, thank you, Gabriel, for joining the show, and thank you, Dominic, for taking out time to co-host this with me. We'll be back next week with another episode. Stay tuned. Till then, join our Slack and download the repo and play out with whatever we have done so far. Thank you.
Hey, thank you very much.